Now I'm going to show you how we can go from a triple where the third entry, the k entry, is equal to 2, how we can go from that to like an xy1 triple. In other words, the kind of triple that we really want to have. And we're going to use this identity here. We've got x1, y1, k1 composed with x2, y2, k2. It's not really an identity. It's just that's what this is defined as. The identity is the fact that this right here, their sum or their composition, the Brahmagupta composition, is also going to be a Brahmagupta triple. Okay, so we're going to begin with a triple. Let's say we have a triple where the right-hand side is 2. So we're going to have x, y, 2. So let's say we have a triple like that, where the right-hand side, the right factor, the third whatever component is 2. I'm going to show you how we can go from there to a triple where the right-hand side is 1. In other words, that's our goal. We want one where that third component is equal to 1. So let me remind you what this means. So the integer n is fixed. So for these problems, the integer n is fixed. So none of the notation has that. It's just fixed. So like this product or this sum here, we might sometimes maybe want to put decorate it with a in here to know that we should be having an in there. But anyways, okay. So this means x squared minus n y squared is equal to 2. In general, whenever we have a Brahmagupta triple, we want to do something to make this go down. So what I'm going to do is I'm going to take xy2 and I'm going to do the composition of it with itself. So we're going to do xy2 plus xy2. Okay, and here's what we're going to get. We're going to get x squared plus n y squared. Here, all the x's are equal. X1 and x2 are both equal to x. Y1 and y2 are both equal to x. So this is just 2xy. And then finally, we're going to get 2 times 2, which is equal to 4. Since this is a Brahmagupta triple, what this means is x squared plus ny squared squared minus n times 2xy squared is equal to 4. Now what I want to do is I want to show that we can divide both sides of this equation by 4. Of course, we're going to get a 1 here, which is what we want, and I want these to both be squares as well. I want this to be a square plus plus n times a square, and those are going to be the first and second components of our Brahmagupta triple. So over here, it's pretty easy to see why we can do that. 2xy squared is equal to 4xy squared, and this xy is going to be our new this xy is going to be our new second component in the Brahmagupta triple. Now, let me rearrange this a little bit. Notice what I can do. If I add this to both sides, I get this equation as well. Now, this right-hand side is clearly divisible by 4. So what it means is this term right here has to be divisible by 4. Okay, so let me put it how it should be. Okay, so this is divisible by 4. Okay, so if this is divisible by 4, the only way that this thing squared can be divisible by 4 is if actually 2 divides x squared plus ny squared. In other words, x squared plus ny squared has to be even. If this equality is true, x squared plus ny squared has to be even. Okay, well, what can we do with that? Well, we can just come over here, divide this by 2, x squared plus ny squared. It's even, since x squared plus ny squared is even, this is going to be an integer, and I'm dividing by 2 squared, so I need to multiply by 2 squared, which is going to be 4. And now what I have, if I divide all of this by 4, I've got x squared, well, let me just erase the 4's. I've got this plus this is equal to 1. And so now my Brahmagupta triple is x squared plus ny squared divided by 2. Then I'm going to have xy and then I'm going to have 1. So in other words, what we've done is if we've got a 2 here, if we have a 2, what we can do is compose it with itself. That's going to give us a 4. And then just kind of based on elementary kind of dividing properties, we see that we can divide both sides of this by 4 to get a new Brahmagupta triple, where this one is going to be a 1. Okay, so notice that if we had a -2 here as well, we could do this as well, because what's going to happen, this is still going to be a 4, and all of the divisibility thing still works. All right, so I've just shown how you can go from a Brahmagupta triple xy2 or xy minus 2, compose that with itself, divide by 4 to get you an xy1 Brahmagupta triple. Okay, so as you will see in the homework, one thing that we can do with this is shortcut some of the computations. So sometimes you'll be doing a procedure that we'll look at that's always that's guaranteed to give you to end on a Brahmagupta triple xy1, but sometimes there will be an intermediate step where you get xy2 or xy minus 2, and from that you can actually apply this rule here to get down to xy1. Anyways, okay, that's it for this video. Those details that I just talked about, you can work out for your own on the homework assignment.